Been lectured to. That's it. Great. Well, good morning, ladies and gentlemen. Welcome to this session of Sustainability Live. We have three speakers for you this morning, and the objective is really to give you a flavour of three rather different companies that have benefited from the developments over the last 10, 15 years, driven by either government policy or changing attitudes to sustainability. I guess we've got a pretty varied audience as well, because given that variety of companies, then some of you may be investors, some of you may be looking at how your ideas around innovation can feed into these initiatives. So I've asked our speakers to concentrate on issues such as the interplay between government's policy, economics, their particular strategy, their highs and lows, and indeed what they regard as their particular IT factor, their sort of unique selling point, which has enabled them through thick and thin to get to where they are in the marketplace now. And our first speaker is Richard Gueterbock. Richard and I have crossed paths since AD was in swaddling clothes in the mid-late 90s, I guess, other than on sort of the odd farm. And we've had debates over the years about where AD sits in the waste energy hierarchy. So I'll hand over to Richard now. He's extremely qualified in the AD sector, but he's also a trustee of the RAIS, the Royal Agricultural Society, who have their base down at Stoneleigh and are doing some very interesting and innovative work in this area on behalf of primarily the farming community, but also the wider waste industry. So over to you, Richard. They've each got 5 minutes apiece, so in the interest of equity, I'd ask them to stick to that time schedule. Thank you.
Thank you, Peter. When a colleague of mine saw that I was speaking at a sort of Dragon's Den-y thing, he said, "Oh, look, the chairman's Peter Jones. Is that the man off the telly?" And I had to tell him, no, it's another Peter Jones, but he's much more qualified to chair this session. But I've spent the last 10 years trying to convince Peter that there was an opportunity for small-scale technology in the renewable sector. Because, of course, he has a background, albeit as a guru of the industry, he has a background in Biffa, and they only do things that cost 10 million quid. So I'm really looking forward to the opportunity to press the button for small-scale AD in front of Peter and the rest of you. Just very quickly, we're a British on-site anaerobic digestion company. We build anaerobic digestion plants on food factories. So we take food residues and we turn them into energy. AD is a much more complicated market than government ministers and other people would have you believe. There's the municipal sector, treating household curb waste from local authorities. There's the farm sector, treating waste, manure, and also farm residues. And then there's the industrial sector. All these sectors will work at a small scale, at indeed a micro scale. I have a good friend who's an engineer in the AD sector. She has an AD plant in her back garden, taking her neighbour's food waste and her garden clippings and heating her greenhouse. So there is a huge opportunity in the food and drink sector to develop this technology. At the moment, we're building plants for larger companies like Nestle and Diageo, but there are hundreds of companies out there that have small production plants producing ice cream, microbreweries, microdistilleries, and they are the people who are scratching their head and saying, how do we reduce our carbon footprint? We've got pressure from the retailers, we've got pressure from other sources to be low carbon, carbon neutral, whatever. Anaerobic digestion strips carbon out of your production process, provides you with green energy, and reduce the costs of effluent treatment. The small-scale solution is there already. The plant at the top there is our test rig that we run trials on people's sites, and we've been running that plant for 5 years. It's got a 10 cubic meter digester. It's exactly replicable with plants that we build that are 100 to 10 times the size. And we're now starting to develop this, and we're working with RAP to develop a brewery project down in Dorset, where we will take a microbrewery's production effluent, put it through the digester, put the biogas into a boiler. The boiler will provide heat to the factory. So it's a beautiful closed-loop solution. We know it works for the larger plants. The challenge is to make it economically viable. And bear in mind, most food companies are looking for a payback of under 5 years, even for sustainable projects. It's a challenge. We're doing 5-year, we're doing 3 to 4 year paybacks with the larger plants, and we're trying to achieve that with this plant. And our first plant will hopefully go into production later this year or early next. There are a huge range of opportunities, and there is, I think, an awareness out there in the food industry now that just calling it waste and tipping it down the drain is not the future. It's costing more, energy is costing more. If you can turn your nutrients, your protein, your fats into an energy source which you can put back into the factory, you are really challenging the future. The problem is that most of the food industry is in denial about the fact they have waste. They're selling their end product, and therefore you have to find a way of de-risking this sort of technology. You can't have the tail wagging the dog. And a small-scale solution provides a solution, but there's also a risk. What happens if it goes wrong? So you've got to have a robust technology, and this is what we've developed. And by selling the benefits of carbon reduction, by producing on-site energy, and ultimately by giving the opportunity to recycle water back into the factory, I think it's a pretty compelling case. And the challenge we face as a business is to say, okay, we've got clients like Diageo and Nestle who are ordering new plants. We need to put more resource into this as part of our business. We're looking for funding partners, be they asset finance partners or possibly crowdfunding, who will work with us, work with these small brand companies, sell the concept not only to general investors wanting to work in renewable energy, but also to the customers of the brewery or the ice cream manufacturer, and give them a chance to take a stake in renewables. So I say that on-site AD is already a major opportunity in the UK. What we're trying to do now is to turn it into a much wider opportunity, to build on what we've done with BB Dairy, and to actually move into these sectors: food and drink, dairy, distilleries and breweries, biofuels, also pharmaceuticals. All those sectors are ripe for the development of small-scale AD, and we're looking for the right funding partners to help us do it. Thank you.
Well done, Richard. Spot on. Now, we've lost our first speaker, Pradeep, but our scheduled third speaker is now numero duo, and I'm happy to welcome Mike Olive. Mike is going to tell us about the work that he's been doing in the sustainable housing sector, and I'm particularly interested in this because in our village we've just succeeded in getting 6 affordable homes outside the village boundary, which is quite unprecedented, but we'll compare notes on that later. So welcome to you, Mike, and looking forward to what you've got to say.
Am I pressing the right one here? Okay, here we are. I'm going to start with a story first of all. About a year ago we were asked to do a review of 3 invitation to tenders for a well-known retailer for one of their manual strategies to get rid of 40 million picks by hand to a fully automated system. We used our CAPEX OPEX modeler to do this, and with interesting results. Nobody had considered the effect of energy. One of the aspects from this came out that their current spend for electrical energy in a manual sense was £850,000 a year. When we calculated the effect of change in the first year of operation, it would go up to 4.5 million. Now you can reflect on the change of dumping a technology onto a process without understanding the process. So the CAPEX OPEX idea works really well in as much that it's a whole life. CAPEX is very much about investment at a point in time, but OPEX is very much about sustainability. In other words, CAPEX doesn't finish. CAPEX is a start point for what you then need to improve upon. It's a continuous process of improvement. All CAPEX OPEX are location dependent. So don't think you can do one CAPEX for somewhere in Scotland and dump it on somewhere else's site and think you're going to get the same results, because you won't. But when you get the CAPEX OPEX process right, it gives you 3 big benefits. One, which is you're totally in control of the finance. The second thing, that every time you use CAPEX and OPEX, it's consistent. So reporting levels are consistent. It has outputs from it in terms of ISO standards, BS standards and so forth, which are deliverables for free because there's only one data source. And it creates trust and habits which stick, because a lot of the work that we do is aimed at everybody within the organisation, so there's responsibility and ownership of that particular product. So that's the opening gambit. There are a number of different applications for for this. I'm now an architect. I design low carbon, low energy buildings. That's kind of what I do. I'm a data engineer, so I understand the performance of buildings and how to integrate these things. But as you've seen at a strategic level, you can use CAPEX, OPEX modeling to do predictive analysis. You can do exactly the same with every project management tool that known to man. Plug it into Prince or Prompt or any of these kind of strategic tools as your vehicle for ROI assessment. I'm interested in buildings because I am, whether or not it's a building like this or whether or not it's housing and so forth. And I get frustrated with the terms affordability. There is really nothing affordable about buildings in the UK at this point in time. The land costs too much, the construction methods cost too much, the materials cost too much, and we fudge the numbers. If 40% of a budget is taken up by services, how affordable is that? And if we can strip out cost of materiality, cost of process, cost of transport, cost of waste, then we start to get to an affordability model. But that's just the CAPEX process. It has to be affordable to run. And so we start to look at innovative ways to enable people to live in these homes so that the cost of energy won't outstrip the rate at which their earnings will increase. And that is a significant problem. These types of techniques allow you to predict that to some degree. Predictions are always to some element a guess, but we can start to manage that year on year. I like BIM. BIM is a new technology which is used by architects. It's building information modeling. It's also business information modeling. It's an information manager. It's all sorts of different things that architects are now using. At this point in time, it doesn't link to the back end, the BMS, the building management system. CAPEX, OPEX does that, and our next tranche of work to evolve our CAPEX, OPEX is to make it IFC compatible, so it will then talk to BIM. So the data we use for CAPEX, OPEX directly links into the structural engineering, the architectural engineering, the energy engineering, and so forth of a building design. We've proven it across a number of different sectors, from the global logistics all the way down through to childcare. My favourite was food production because it was about chickens, so chicken farming. So our unit of measure was a kilogram of chicken or carbon per chicken leg, and so on. And so you can have a lot of fun with data when you're starting to manage it. To take this through to its end conclusion, what we've now developed using these CAPEX, OPEX models is to integrate them so that we can pick the right technologies for a building, the right construction methods, the right processes, the right materiality, and turnkey solutions. If 40% of this is based on service and you want to strip out the service waste, then why not turnkey some of these solutions? There is no point in redesigning buildings after buildings. In the 1930s, 2.6 million 1930s semis were built. They are still being sold today and highly valued. The Victorians did it with Victorian semis. But what we seem to be able to do now with affordability is make them unique. At the end of it, this is all holistic. There's no such thing as a silo-based process. If you're looking at data, you need to look at processes, transport systems, supply chains, and so forth. Just one word of interest on transport. Our attitude to transport is not about something that has wheels or a boat or an aeroplane that transports materials from one place to another. It's everything that flows. Transport systems also include information data and data, how you get data from one place to another, how you get cash from one place to another. Anything that moves is a transport mechanism, and that needs to be optimized in your CAPEX, OPEX. What we do is fully integrated. There's no such thing as a silo for cost and revenues, a silo for energy, a silo for carbon, a silo for risk and time. All of those things have to have a unique or have a recognized value within a single process. Revenues is important because we fundamentally believe that sustainability is a revenue center, not a cost center. Waste is a value, waste has opportunity. And all the time you can turn everything that you do into real value. Whole life cycle from baselines to concept, all the way through to design, through installation, and then eventually through operation. Sustainability is operation. That's the OPEX element of this. I have yet to go into an organization that manages its OPEX. I've yet to find an organisation that integrates costs and revenues, energy and carbon, and manages its risks at an OPEX level. How do they expect to be sustainable year on year from that original investment profile? We want to make BIM and be part of that BIM process to make that a national standard even more through integration. And at the end of it, we've got these location solutions, whether or not they're tiny projects or whether or not they're comparison of solution sets, turnkey buildings or custom work and so forth. And at the end of the data, it's your data that counts. I'm really arrogant with data because I know it works, and also because it's not mine, it's yours. And so it's very easy to be arrogant with data. It's big data because it has 1,000 uses, it's consistent in views and reporting, and at the end of the day, sustainability is about assuring habit. Well, I don't know how long that took, but that's about 5 minutes, so that's me done.
Pretty much there, yep. Thank you, Mike. Our third speaker is Robin Buller. He is Director of Business Development at Prostream, and he's going to be talking to us about the work that they're doing in the power and electricity sectors. And Robin has a background in petrochemicals. Geographically, he's roamed afar. He's got wide experience in the Far East, China, and in New York as well, but around the nexus of energy and electricity. So over to you, Robin.
Thank you very much, Peter. I'm here to introduce what KRR Prostream does to help the waste-to-energy business become more efficient and reduce its emissions in the energy from waste power stations that are now dotting the country and are increasing all the time. What KRR Prostream does is provide services to these companies that allows them to improve what they do all the time. And we're talking about taking the waste, that municipal solid waste that we all put in our black bags, and instead of going to landfill, it's turned into energy which is used in our houses. So making these companies more efficient is not only good for them economically, but also good for the environment, because by a greater efficiency, reduce the emissions and improve the amount of energy that they can produce from the actual waste itself. So you get better bang for your buck out of the work that they do. So we work with a number of different power stations around the country, a few demonstrations here. The one with the blue sky is my own personal photograph. The others are corporate ones, but you can see I chose that one to show how clean the power stations are after we've used them. But what do we actually do for them? Well, I'm not going to go through all of our services because that would take too long, but I'm going to show you one of them that is really quite important and probably something nobody's really thought about before, but it's very important for all power stations, including gas and coal power stations, but I'm focusing very much on energy from waste and also biomass power stations today. So we clean their boilers. Now, typically when you clean a boiler, you have to let it cool down. Somebody goes inside it. They either abseil or they set up scaffolding, and they take a hammer and they remove the fouling. This is fouling from a boiler. This is biomass. This is what happens to wood when it's heated up to about 900 degrees and heats and creates steam to make electricity, and you get fouling on tubes. This stuff is really hard, and otherwise you go in and knock it off with a hammer or a metal pole. That's how sophisticated it is. Not very sophisticated. So what we do is we take a bag like this, which is then inflated on the end of a lance inside the boiler whilst it's on, and the temperature inside the boiler is, any guesses? Okay, I'll tell you, 900 degrees centigrade. So you can't go in there and start knocking the fouling off with a hammer because you wouldn't last very long. So we put this in whilst the boiler's running, not only saving the power station time, but also allowing them to avoid the costly shutdowns that they would otherwise have to do to clean the boiler. The boiler doesn't work properly, you get lower production. If you close a power station, turn it off for 24 hours, you can be talking about a loss of a revenue of £70,000 per 24 hours. And that is from the power stations' mouths themselves. We know that. So it's a big loss if they have to close down in an emergency. So we go in, we fill this bag, as you can see here in the third picture, with a mixture of ethane and oxygen, and then and the final picture shows we detonate it. And it's called pressure wave technology, but we call it bang and clean, because bang is the bang, and clean is the effect of the pressure wave across the tubes and onto the sides of the boiler, and it shakes them, and the fouling that I've just shown you falls off to the bottom of the boiler, where it can be removed in normal fashion in the systems that the power stations have. It's a terrifically effective system. We can go in and we can clean a boiler in a 12-hour shift, which would otherwise take a cooling down time of 3 or 4 days and maybe 2 or 3 working days. So a 7-day job would be reduced to a 1-day job with our technology, and saving them a lot of money and time. And what are you actually seeing here? You're seeing the tubes going from this, which is fouled with this material here, to this, which is clean tubes. These are clean tubes done by us, just showing you the enormous difference that it makes. Now, today we send our teams in, they go in, they do the job, but the future is a more permanent system. So we can attach these units to the side of the boilers, and instead of going in every 2 or 3 or 6 or 7 or whatever number of weeks we have to go in, traveling, using valuable diesel, we can put one of these units on the side of the boiler, and it goes off on a regular basis, keeping the boiler clean for months at a time. A bit like, rather than washing your car every month, which of course you have to do if it gets very dirty like mine does, what you do is you wash it every day. I don't have that facility, but if you had one of these pieces of equipment, it cleans the boiler and maintains its optimized performance for a continued period of time until you have a general shutdown in the plant. So really, that's a simple way of showing you how we can provide excellent services to the power stations that take waste or biomass as a feedstock and turn it into electricity. We reduce their costs, improve their efficiency, and maintain and improve their sustainability as time goes on. So I'd like to thank you very much for listening to this, and if you have any questions, I'd be willing to take them afterwards. Thank you very much indeed.
Thanks very much, Robin. Well, 3 quite distinct speakers there, but around a theme, really, of getting lateral thinking into a whole series of process. One about scale, in the case of Richard. One about systems thinking, I guess, in terms of Mike. And then finally, from Robin, I guess, maybe regulatory blockages and internal resistance from the engineering functions. Can I have questions from the floor, ladies and gentlemen, about any aspects of challenges or questions that have been raised by these presentations? Thank you very much indeed, sir. If you'd just indicate who you are and where you're from, that will, and to whom you're directing your question.
Sure. Thank you very much. Gil Levy from Sustainable Development Capital. We're an investor in energy efficiency projects in the UK, including biomass, buildings retrofit, CHP, and so on. Really a question for Richard, and thank you all for the presentations. How you talked about small-scale projects, the pilot projects. How do you scale this up? For an investor, you can probably spend the same amount of time on a £100,000 deal than you would on a £100 million deal. So how do you ensure that you have a pipeline and a series of projects that can form an investment of £5 to £10 million?
I think that's the universal problem for all of us who are trying to market small-scale on-site technologies, be they AD, hydro, whatever, is you as an investor have to do due diligence. And hopefully the way you can do the due diligence is to look at the plants we've already built that are a larger scale, because we can replicate performance, and then we can build a pipeline. We're not trying to, with Diageo and Nestle, we'll build one plant one year, maybe one plant the next year. With these containerized plants, we're looking to get a pipeline going so that we'll be building 5, 10 a year, because that'll help us drive the cost down to a point where it's really economic for the smaller guy. So I think it's trying to package a number of projects together, either in a sector, the brewery sector, or in a part of the country. We're talking to a partner in Scotland, for instance, who wants to partner with us to deliver those projects. He'll bring the delivery mechanism. We then need to find a financial partner to sit alongside him. So I think it's multiplying projects together is hopefully the solution that you guys will find attractive.
And I guess generally 100 million for innovators in this sector is the sort of level that gets you guys interested in it. I've heard that number in the last fortnight actually from another character who was looking at companies existing, and there aren't that many companies with a 100 million tag in the sector as yet. I'm just wondering whether our speakers have a view as to where that sort of funding gap might be filled. You've obviously relied on subsidies or grants and so on to initiate the process?
Well, perhaps I could come back at you, Peter. One of the problems we face in the anaerobic digestion sector where I work is that your friends at Biffa and CETA kicked this off 10 years ago and told the government you could only build plants that cost 10 million quid and they had to be huge, and actually biological processes don't always work terribly well at a large scale. So I think we have to be more aware of the type of technology we're using, of whatever type it is, and actually develop the funding mechanism that fits the technology, not just say because the big companies operating in the waste sector can only do large projects, we do large projects.
Sure.
And I think therefore you have to be creative. You know, we still have to we deliver a 20 to maximum 5-year payback on our plants. We won't get food companies to talk to us if the payback is more than 5 years. That's about half the merchant sector. The challenge for these small projects is to replicate that, and that's why we've got to drive the manufacturing costs down and make it look attractive to people like Gil and other investors and asset finance.
Sure. And your typical investment would be 5 million.
The biggest plant we've built is 4 million, and that was for Diageo. And it's a small plant by comparison to Biffa's plant at Cannock.
Yeah, you'd be looking more typically there around about 20 million, 20,
I'm having
25.
a battle with the Green Investment Bank, which claims to be a green bank and claims to be keen to invest in small projects. They're only investing in mega incineration plants. There's nothing green about what they're doing, and they can't invest below 2 million.
Sure. Yeah, they do have their own challenges.
Sorry, I better hand over to somebody else.
Yeah, and I think also that you've got these plants that are producing a power source, whether it's gas or into electricity, and also you've got the feedstock, and at least you can guarantee that you're going to be able to sell the power source, and you're going to be able to get the feedstock over a period of time. So from an investment point of view, your input and output, these, whilst the numbers may change in terms of value, at least you know you've got them guaranteed, and you can lock them in for a period of time, whether it's off-take or whatever. So I think it's a good business for investors because at least they can see down the track a little bit, and notwithstanding, of course, government policy changing occasionally, which is something I know Richard has faced a little bit.
What sort of support did you get from the regulators in terms of entrenched opposition, or was it supportive generally? I'm conscious with different technology areas where it's very difficult to nail somebody who will actually give a definitive judgment until, it's a bit like joining equity. Until you've got a plant, then they're not interested in approvals, and you can't build a plant without approvals.
Well, I think anybody that's building waste-to-energy plants particularly are finding that it does take, it's a lead time of about 3 or 4 years before you actually can even, start digging the hole. And it's a very problematic thing. The thing is that there's very little alternative at the moment, and I think that down the track there'll be more recycling, more, if you like, streaming of materials, and then you get more efficient plants, and instead of putting it all through one, which is what we do today, we put it straight into a waste-to-energy plant. It should be broken down so you can put some of the more cellulosic biomass streams through anaerobic digesters and other streams through other systems so that they can improve the production.
I would just comment that for a plant being built on a food factory, the regulatory challenge is much less because it's already designated as a planning zone. And if you're building a containerised plant, it's even easier to get planning permission. The real challenge is working with SEPA in Scotland and the Environment Agency in the rest of the UK, and you've just got to engage with them and tell them what you're doing. Funny enough, the biggest problem we ever had was with our first plant on a dairy. It was part funded by DEFRA, and the biggest problem was the government vets, which is an agency of DEFRA, protecting their backside because they'd never seen anything like it before. So.
You okay, Mike?
Yeah, I can answer it in a different sort of way. Back to our first example with the organisation that wanted their automation system. Part of their remit was to expand their business from 40 million picks a year to 90 million picks in half the space. They achieve half the space still with a manually revised system. That space has a colossal value. And funding isn't always about going out and having to find it from new sources. It's about making it. And what that organisation did was to look at the different spaces they had from a business model. At that same time that we did our review, they hadn't considered the effect of buying online. This was always buying through stall. It was a business as usual model, which they expected to maintain for the next 10 years. That space that they created as a result of the change enabled them to transform their business into a completely different empire. So it isn't always about having to go out and get expensive funding, which is difficult to get. It takes a long time to realise. It's about making it. And so when we talk about waste, we're not talking about physical waste, which is incredibly important, but it's about waste of space, waste of time, waste of opportunity, waste of all of those soft things that you can turn into real ideas and make money from them. Incidentally, on that particular issue, that one warehouse, which was 650,000 square foot, was paying £120,000 a year to a certain water board to take the rainwater off site. Why not capture it? Why not sell it? Why not reuse it? Why not do all of these things instead of paying people's bills?
And we've got a few people down those aisles over there that can certainly do that for you.
Hi, I'm
Yes, sir.
Roberto Vogel. I'm the owner of KRR that operates the boiler cleaning.
Right.
I just want to answer a bit more into how we are affected by regulatory or government help. As far as I can see, there isn't any. But I can see that there is a possibility of people like NISP helping us to develop new products. For instance, we now have, we're using one of our cleaning systems for heat exchangers on a novel industry, which is what is this, Simpson's malt? It's malt
Right.
Production, and we never tried to get funding, and maybe somebody could help us with that, because we believe we are bringing a technology which is for air-cooled condensers in the energy from waste sector. We're transferring that to a food industry. Another thing, just quickly, if I can just put another little tube through. We believe that the breath notes which come from Europe, they should include more instruction and more information on these cleaning systems, on optimization with energy, and the new breath notes are coming out. I'm lobbying with the Spanish office to help
Get
with
that included.
but it's very difficult. So I would welcome any help that we could be given to do that.
And it sounds as if your system is a subset of the sort of stuff that Mike might be doing on a more macro sense.
Mm-hmm. Just to pick up on the breath issue, the trouble is with anything coming out of an European Union or a government agency, they're not going to be up to date on technology. We have the same issue with anaerobic digestion. The data in breath on anaerobic digestion is 10 years out of date. They're trying to update it, but whether they can understand the difference between what's available on the market now and what's available 5 or 10 years ago, they're not commercial people. They just don't understand it.
But that's the efficiency of data. That's why the CAPEX element, if you don't get your data right at the beginning, your OPEX is just going to get screwed later on because you're using out-of-date stuff all the time. So the whole thing is front-loaded here, which is if you do an engineering spec of whatever it is you want to do, you front-load this with real data, up-to-date data. And if that takes you an extra month, a week, or whatever it takes, you get that data right at the beginning. If you don't, you'll pay for that later on.
You're all dealing in different ways with senior management in across different sectors. How far do you think British management generally is prepared for what I guess is part Six Sigma, but is not Six Sigma? It's something else, isn't it, Mike? Or is it utterly different? But what's the mentality at senior board level on these things when you're effectively coming in and all of you are offering disruptive routes in either engineering, energy, or more broader contexts?
I think they sit back with a gasp when you play back their own numbers. As I said in there, which is that I can be arrogant with it because it doesn't belong to me. It's actually their numbers that we deal with. But luckily with that one example and others that we've got, they respond to it. So that £15 million investment was canned for a manual system. which got them into social responsibility because that employed staff rather than killed them. It got into environmental stuff in a big way because they started to deal with materiality different. And it got into energy because they then stuck PV on the roof. And so you start then using these types of ideas, not just to save, but also to make. PV and all this kind of energy generation stuff, if you get it right and you get your demands down, is a massive revenue stream. And once you start educating people in the mechanics of doing that, it's incredibly infectious. At the lowest level, they even have whiteboards with people writing on them with their latest ideas and all the rest of it. And they use it. And they reward people because of it. And I think that that's brilliant.
Yeah, we try and offer analysis to plants which can show them exactly what will happen if they take on our technologies, how quickly we can improve their bottom line. The cost of doing it is minimal compared to the benefits, not just short term but long term. And some of them take it on, some of them don't. It's very strange. I never quite understand, but as soon as we can get to the chief financial officer, then they start listening because they can really see it. But it's difficult at plant level sometimes. They don't have the time and the access to the information to be able to allow us to help them. But once we've got in there and shown them, it really does make a difference.
I think the biggest challenge for us is we are providing a technology that is non-core. If you're producing chocolates, you're producing chocolates. Your information systems are directed towards the performance of your product, whiskey, cheese, whatever. That's why we have to provide a technology that's unobtrusive, robust, and we don't have the tail wagging the dog. And particularly for these smaller plants, we're probably going to have to operate them ourselves, which is fine. It gives us another revenue stream, but getting from the plant manager to the finance director is a challenge. And just to give you an example, the biggest food factory in this country is Heinz in Wigan. It's a massive factory producing all those cans of beans and hula hoop rings and things like that. They spend about £4 million a year disposing of their production residues on that site. We've spent the last 5 years trying to tell them that there is a better solution out there. But if there is a non-functional connection between the operations people and the finance people in the factory, if they're not getting the information, it's a very, very hard job to crack.
Yeah. Fine. And one final note from Mike.
On that issue of selling what you do, we've been asked on a number of occasions to help organisations sell their products upstream because they have a difficulty in trying to get these messages across. They're using this as a service now to help organisations that are not getting into energy and carbon management or into financial planning and CAPEX, OPEX, but to do their work for them, either by providing people and skills to do it or by providing methods and so forth. And if you collaborate with these organisations during the selling process as opposed to just drop an ITT through the box, then I think that's part of the process of introducing these new ideas, new data sets and so on. The data's out there. We know how to structure this. It's been done for years and years. It's just, however, understanding that vocabulary and how it's presented and what it means.
Fine. Well, the common factor in all this, of course, is the inevitability of time rolling by, and I'm afraid that principal factor, which we can't do anything to alter, has overwhelmed us. So I thank you for your questions, and can I ask you to thank the members of our panel, Richard, Mike and Robin, for their contribution and hopefully for shedding some light on the darker corners of the opportunities in the environmental revolution that's occurring. Thank you very much.